So example number 3. For example number 3, we have here is a truss system shown. Compute the axial stress for members BE. This is BE, CD, and FG. This one. So we're going to determine the axial stress. What does it mean? Since mag-get mata sa iyang axial stress, we have to determine first the axial forces inside these members BE, CD, and FG. How do we solve for these forces? We have to go back to statics for the analysis of trusses. Remember that? So in analysis of trusses, there are 2 methods, diba? So you have method of section and method of joints. So these are the 2 methods in solving for the analysis of trusses, in solving for the forces inside these members. So we are going to go back to statics. So erase sa nato, and then we may proceed. So unsay buhaton di ay? First is, let us recognize first the reactions being used. At A, there is a hinge. So for hinge, what we're going to do is provide horizontal and vertical components. So I'd like to have here the direction of this A horizontal, and then I'll have A vertical. Then for G, as you observe, it is a roller. So what are we going to do for a roller? Substitute that with horizontal. And I'm going to have a direction opposite to this. So that's GH. So we have the naming of the reactions. So what are we going to do first is solve the reactions. How do we solve for the reactions? Let's start. Let's start with summation of forces vertical equal to 0. Upward positive, downward negative. So what are the forces along the vertical alignment? You have A vertical, upward, and then minus 30, and then minus 30. So these are the forces I'm looking at. And that's equal to 0. So therefore, A vertical is equal to 60 kips. By the way, we call kips as equal to kilo pounds. So 1,000 ka pounds ang naa sa 60 kips, or naa sa kips rather. So that's the value of our reaction, but that's not the correct or the values that we are looking for. Remember that we're looking for values of force BE, force CD, and force FG. So mo ni atong kinahanglan nga mga forces. So let's go back. Then natay A vertical. Then what are we going to do next? Let us solve for either sa duha. So let's solve for that. Solving that, we could have summation of moment, because we cannot do the summation of horizontal forces, because as you can see, there are only 2 forces along the horizontal, and then unknown pa gyud, so we cannot solve anything. So summation of moment either at A or at G. So in my case, I'd like to solve for A, so I'll take up moments at G. equal to 0. Clockwise positive, counterclockwise negative. So what are the forces that will rotate at G? You have AH. So negative AH times 18. And then you also have 30. This one. 30. Clockwise. 30 times the moment arm. From this, padong diha. Pila na siya. That's 16. And then ang rotation is clockwise, so positive. Then another 30. This one. So you have plus 30 times the distance from here padong dira. Pilay distance ana? The distance is 24, and that's equal to 0. So what is now the value of our AH? So let's solve for AH. You have 30 times 16 plus 30 times 24 divided by 18. So the AH is 66.667 keeps. And we obtain a positive value because our reaction or our assumption for AH is correct. So let us continue. Let's solve for GH. How do we solve for GH? Solving for GH, we can now have summation of forces horizontal since AH is already known. So to the right positive, to the left negative. So what are the forces for horizontal? Only GH and AH. So therefore AH di is equal to GH. So GH is now 66.667 kips. So that's the reaction of the supports. So what are we going to do next? Since we're going to solve for this one, BE, ang buhaton na to is we're going to cut through the segment, cutting it here, and consider the right side. So unsay makita sa kanang nga cutting? Ang makita nimo is this one. I'll just draw the figure first. The cutting there is somewhat like this, and then you have here. And also this one. So that is the point of cutting. So here at the cutting portion, naa kay mga forces nga moagi diha. We call that as force FE. Then also naa kay force nga moagi diri, and we call that as force BE. And then we also have force BC. So our objective is to solve for force BE. So saan na to siya pag-solve? How do we solve for this one? Solving for this, ang buhaton na to kay butangan na to direction. And do not forget, by the way, na atay force diha 30 and another force dira nga 30. Sakto ba? Yes. And then this is 2 meters, 2 feet. And we're solving this. So ibuhaton na to. We have to use the summation of moment here. At this point, the point there is D. So mag-moment ta diha. So unsaon pag moment nga naa man kay force nga naka-incline. So butangan sa nato siya direction. So for the force direction, you have butan na lang nato nga tension or compression na lang. So let's have it compression. So with that, kaya ang atong force is inclined man to a certain angle from the horizontal equal to theta. We need to solve first the theta. So how do we solve for the theta? Solving for theta, it's going to be here. This one is theta. So kanisha, this is theta. And then also, this is theta. If we're going to consider the whole triangle, this one, we can get the value of theta. No? So, let's solve. The whole triangle, it says there, nga ang iyang total length is 3 katag 8. So, that's 24. And then, naasag kay vertical, nga 18. And this is your theta. So, the function would be arctangent function or tangent function of theta equal to 18 over 24. Masolve si theta. So, the theta is arctangent of 18 over 24. 36.87. 36.87 degrees. So na natay value sa atong theta, we can now get the component of this force. So kung saan natin yung component, let's use a red component for this one. This is FBE, and that's equal FBE sine of theta. And then naasad kay horizontal nga FBE cosine of theta. And then mag-moment ta diha. So kani nga force, kung mag-moment ta diri, it will just pass through here. So therefore, ma-eliminate siya from the equation. Also, this one, muagi sad na siya dira. So matangtang sad na siya. And also, the component nga muagi sad na dito. So matangtang sad na siya. So ang final nga drawing would be like this one. The force nga 30, and this one na. So ang magpabilin lang kay ang component, the component nga gikan sa FBE. So ang component nga FBE sine of theta. Yung layo kini siya. Diri natin ibalhin. So ibalik na to ang force nga 30. So ang katong force diri pod nga 30, ma-eliminate ra pod siya kay diha man ang moment nato. And this is 8 man din 8. This is 8 feet. So kung ano na to iyahang moment, summation of moment here. So what do you think? Summation of moment at D equal to 0, you will have FPE sine of theta times 8, and it is counterclockwise, minus 30 times 8 equal to 0. So therefore the our FBE is equal to, i-transpose na to sa other side, mahimo siyang positive. Mahimo siyang positive 30 times 8. And do not forget nga na kay negative dira. Yeah, you have sine of theta times 8. So for the force BE it's equal to negative, ma-cancel out na no, 30 over sine of 36.87. So that's our FBE. So FBE is 30 over sine of 36.87. That's 49.999, or that's 50 kips. And we obtain a negative value. So negative value means our assumption is wrong. Wrong assumption. So what are we going to do? Let's correct the value. So FBE is equal to 50 kips. Then our assumption for this one is compression. Yeah, wrong ang atong assumption nga compression. So therefore this is tension di. And this is our force for the FBE. So since na naman tayo force sa FBE, we may now proceed in getting the stress. So stress for BE is equal to, stress for BE, you have FBE over area sa BE. But ningon ang problem that the area daw of every, or the diameter of every section is 3. So yung gingon, inch diameter. 3-inch diameter daw. So ang buhaton na to, let's write $50 kips over pi times 3 square over 4. So this is our stress for BE. So that's 50 over pi times 3 square over 4. 7.07. So 7.07 kips. Then ang unit sa area, square inch, or this is KSI. And this is our final answer for